Welcome, everyone. It's great to have you here, and thanks for taking the time to talk a little bit about Edge to Cloud Solutions. My name is Bill Bass. I'm the VP of Engineering for AWS. Our team runs about 80 different services here at AWS, including IoT and Edge, and some of the other things we'll be talking about today, along with real-time streaming. So a lot of it's pretty relevant to our discussion. So first of all, let's all level set on what the Edge is, because I'll be doing this presentation from the Edge back to the cloud and how things integrate across there for your best business value and what you're looking for to deliver to your customers. So what is the Edge? So the Edge might be robots, for example, and things like that in a house. iRobot's one of our customers. They've got millions of robots running on RoboMaker and our IoT systems and things like that. It could be an ADAS or driverless car system, or connected automobiles. We sort of lead the world in connected automobiles, and most of the cars you'll interact with today that are connected are using AWS in one way or another. And more and more driverless cars and ADAS or autonomous driving collection is happening in automobiles. Or you might be in the hospital using Philips medical equipment and things like that, and those are connected through our IoT systems. That would be an Edge example as well. Or you might be out on a ship or an airplane or an oil rig. All those things are considered the Edge. In fact, unless you're sitting in the AWS availability zone or one of our data centers, you're at the Edge right now. So most likely you're at the Edge. And it's really important to customers where they need to do very high value or very rich interactions with customers at very low latency. And so we want to be able to deliver to the Edge as seamlessly as we deliver to the cloud. But what we're dealing with at the Edge here is running workloads that have to deal with these sort of three laws that we always talk about for the Edge. So first of all, you have the law of physics. We can't exceed the speed of light, at least not yet. And so there's a latency requirement. So when you're doing a driverless car, you're doing a robot or a SCADA system or a PLC system, you have to do that processing right there on the Edge. And a lot of times machine learning needs to happen on the Edge, so we might want to make it easy to deliver that at the Edge. The law of economics. If you're shooting a movie, which a lot of our customers are doing, or you're collecting seismic data or other very high value, very large data sets, it's just not economic to send those over the network because they're just too big. And there's the law of the land, because sometimes you have data residency requirements that require data to either be in a country or a specific location. And so all of these are Edge challenges that we have to deal with, and you have to deal with in delivering customer service with your applications. So our goal here is to give this centralized control and decentralized execution. So you can have the beauty and centralization you have in the cloud and the control that you have in the cloud, and be able to execute things at the Edge. So we are building a seamless, integrated development environment, connection environment, deployment environment, management environment, and security environment with a common set of APIs from the Edge all the way back to the cloud. And it allows you to manage the Edge, deploy to the Edge, and really save money on how you develop things, because you can develop in the cloud, test in the cloud, and push out to the Edge and manage from the cloud. So this single end-to-end management and deployment and security environment is really important to our customers, especially the security environment. We hold a very high bar at Amazon on security. In our Edge to Cloud architecture today, we kind of break it out into these areas. So we have microcontroller and IoT devices. That's actually doing execution on the device, if you like, and connecting back to the cloud. We have networked environments. Those are environments where a lot of those devices work together for a common cause, like a refinery or a hospital or a production facility or manufacturing or shipping logistics facility. We have networked environments. These are where these environments are connected in through a telco in 5G and taking advantage of the low latency and higher bandwidth you have with telcos and 5G. The rugged edge, so these are in disconnected environments where you're out running in a place that isn't a good data center environment, like on a helicopter, in an example there, or on a ship, or on a movie shoot, or a drone collection, or an oil field, or a ship, things like that. We have on-premise environments where customers want to extend the cloud into their data centers or into their network rooms and things like that, and metro centers, which allows you to run the full AWS scalable services right in a local metro. For example, in our LA metro area, the movie industry can do real-time video editing and take advantage of the low latency connectivity right to that. And then, of course, at the cloud with our regions, POPs, and availability zones, things like that, You get huge amount of durability and the advantages of the cloud there and the infinite scale of the cloud there. And we have a very prolific number of regions and availability zones out there. And our regions are already always broken into multiple buildings that are physically separated 10 to 60 kilometers away from each other to protect your data at the edge. So if we look at our architecture here, this is what we'll be talking about from the microcontrollers all the way back to the cloud. These are the different services I'll be covering today. So let's start with the microcontroller and device architecture and the services for that. So the first thing is for microcontrollers. So microcontrollers are very low power processors, very low energy use, generally speaking, and embedded everywhere in your car, projectors, TV sets. You interact with them all the time. And so FreeRTOS is an open source product that allows you to run at the edge, do local connectivity. And these are devices that are not powerful enough to run an operating system. So it handles all the platform capability necessary to run right on the device. We provide cloud connectivity to make it really easy for you to connect those devices back to the cloud. We provide security and the ability to management over-the-air updates with code signing. So that, again, security is a top priority for us, and long-term support, because a lot of times these devices are embedded in cars for 10, 15, 20 years, things like that. So you need long-term support. And again, it's open source to allow you to see the code, maintain the code, and interact with the code as well, and get updates from us on a regular basis as we advance the product. As you move up the stack, if you like, in capability to a device that can run Yocto or Linux or Windows or things like that, so it has an operating system, but it's still a small device, then we have Greengrass. So Greengrass is also open source, and it provides a secrets manager, so you can do things like soft SIMs to connect to multiple cellular networks, things like that, and manage your security. It provides local messaging within the device and between devices around it. You can do local actions, so you can take Lambda functions and scalar vector models and things like that and run them locally on the device, again, managed in the cloud and deployed to the device. You can deploy containers to the device. The device is powerful enough to run containers. Stream Manager is one of my favorite things. It allows you to kind of move between doing, asynchronous and synchronous communication. It can discover all the radios or connectivity on the device and choose to do the lowest latency or fastest connectivity or cheapest connectivity or delayed connectivity, all those things without the complexity of you managing as a developer. And then, of course, most of our customers want to run ML on the device. So we have a whole ML interface and the ability to manage models on the device. So, for example, cameras and things like that, where you're doing object recognition or LiDAR and things like that. So Greengrass is a great platform for that. Again, open source to give you a lot of flexibility there. We have a lot of industrial partners that are using our platform today. We connect about 1.4 billion devices under management today and growing at a tremendous rate for external devices, and another around 300 million Amazon devices. So we have very large scale that we can manage today already. Siemens is one of our core customers here with MindSphere. They're built on top of our IoT platform and integrated with it. They're at about 80% of the worldwide industrial edge environments and automation there. And so they're a very large, capable partner that we hold very close and do very good work with, along with a number of other partners around there. They're used to running at very high SLAs for factories and things like that, built on our scalable and secure platform. Carrier is another customer partner where we manage cold chain for them, for example, for distribution of vaccines and things like that, reduce waste. A lot of this is all about reducing waste, improving your availability, reducing downtime, or in the case of Carrier, really managing the whole end-to-end cold chain so that you have good produce that you're being delivered or good product you're being delivering without losing any product out there. A lot of our customers want to do proactive maintenance because that's really, really important at the edge. For example, today they'll send their support people around to thousands of locations to check to see if something needs to be maintained. As you move to the ability to stream that data in and run machine learning across it, so you can take advantage of machine learning to identify anomalies and tell you when the device needs maintenance, that'll save you a tremendous amount of money both in downtime and having to go to all these locations. And so we have a product called Monitron. So if you don't have a lot of connectivity, you can run Monitron, which is a device you can hook up locally. and look out for equivalent machine learning right on the device with very little experience. You just kind of hook it up, connect it, and start running and taking advantage of it. If you can stream the data back to the cloud, because a lot of our customers have great connectivity for that, all that data can stream to the cloud, and all those same things can happen in the cloud. It can automatically detect when something needs to be maintained, automatically detect anomalies, those kinds of things can all occur for you back at the cloud end. So very flexible here to run at the edge or back in the cloud. We have a product called Kinesis Video. So Kinesis Video runs on millions of cameras today, along with LiDAR and radar and other things like that, sonic sensors, anything that's a frame series time data can be streamed in with just 5 lines of code on Kinesis Video. Numbers of our customers are saving millions and millions of dollars, hundreds of millions of dollars by moving from proprietary camera systems to a Kinesis Video-based IP system inside data centers and buildings and cars and things like that. And Kinesis makes it easy to stream that data back so that you can process it in the cloud. A lot of our customers, though, have older camera systems, and you can use, for example, Panorama with both new and old cameras, and it will do that machine learning for you locally. And then if you want, you can stream the video into the cloud with Kinesis Video. If you have smarter cameras, you can run that on the camera and run that machine learning on the camera. With Lookout for Vision, you can stream to the cloud and run the machine learning in the cloud. And what customers are doing with cameras are pretty amazing today. You'll see examples of it later with some of the videos I'll show, but they're turning cameras, inexpensive cameras, into very robust multifunction IoT devices. So for example, you could have a camera looking for defects, a camera counting number of people or number of cars in the parking lot, or routing traffic, all those kinds of things. As opposed to having hundreds of sensors to do that, you can do that with a few inexpensive cameras using machine learning. Pretty exciting how that's going. And a great example of that is what Cargill is doing. They used to have a person watching cameras, and when a truck would come into their depot, they would they'd look at each dock and say, go to dock 6 based on the size of your truck, and that dock 6 is open. Now the cameras are looking at the vehicles as they come in, looks at the size of the vehicle, knows where all of the docks are open, looks at the traffic, and automatically routes to the best location to save a tremendous amount of time and money in their distribution system. So it's a great innovative use of camera intelligence, if you like. So let's talk about networked environments, because that's where you want all these devices working together. So you might have, say, for example, a refinery where you have hundreds of thousands of sensors and you're getting the data in real time. So with SiteWise, it gives you the ability to see what's going on, to set up asset models, set up tipping and queuing, set up alarms, set up a logic on how the devices will work together, and really get a good sense to really optimize your manufacturing. So some of our customers are saving 30–40% in their operations by deploying things like IoT and SiteWise together. So there's a lot of good business value in this as well. In addition to that, we have the ability to run SiteWise on the edge. So if you get disconnected, you can keep running, or for very low latency, and it'll run on snowballs, which we'll talk about later, and outposts, which we'll talk about later, or really any qualified hardware device as well. Volkswagen's a great example of this. They're looking to save 30% in cost and speed of operation reduction. They're deploying it across 120 plants. They're deploying our IoT systems and our outposts, and really they're a close, good partner as well in the development of this as we deliver it out in their what we call the digital production platform that they're deploying. So it's a great example of kind of using all the products we'll talk about here today. A lot of companies are doing robotics to automate manufacturing, automate logistics, or in the case you're seeing here, this is a sterilization robot here on the left. Well, robots, the hardest part of a robot isn't building the hardware. The hardest part is designing the software, building the machine learning, and all those things. So RoboMaker makes it really easy to design your software, deploy it in management across robots, test it in a virtual environment. We have the ability to generate virtual environments, as you see there with the hospital, and then deploy out in your factory floor or deploy in your logistics center. So it's an end-to-end development and production and deployment environment for robotics and autonomous systems. Millis is a great example of that. They needed to build a sterilization robot for hospitals that had to turn off its UV lights when people are around, find its way through elevators, train it in hospitals. They use RoboMaker and WorldForge and things like that to build simulations, do the training, and then RoboMaker to deploy it out on the robotic systems. So let's talk about edge environments related to telco and 5G and what's going on there. We have Wavelength being deployed out right now with a whole bunch of partners. And this takes advantage of the hub and spoke architecture of 5G. And in that hub and spoke architecture, you have very low latency, but you now have these AWS services right there in the 5G hub that you can deploy to, in addition to the telcos being able to run their soft switching and soft networking components right on top of a software-defined networking environment right there. So it sort of serves a dual use, both for the telcos and a multi-tenant capability where our customers can deliver there. This is great for gaming, where you want to do very low latency with your customers, or robotic control or manufacturing control, things like that from the 5G hubs. So it saves you a lot of money and really makes it easy. So we're going to show you an example now of what Tata, one of our partners, has done with 5G in manufacturing.
Hi, I'm Shanky Vishwanathan, CTO for Communication, Media and Information Services at Tata Consultancy Services, TCS. We are developing a lot of innovative solutions around smart factory, which necessitates high bandwidth, high reliability, and low latency requirements for a connected digital ecosystem within the shop floor. Let me take a particular use case within the industrial manufacturing setup, which is called end-of-line quality control. Traditional approaches have been either manual quality controls or very localized edge systems doing visual analytics. In this pilot with Verizon and AWS, high-resolution cameras take video and stock images of the objects passing through the production line. These are shipped through Verizon 5G to the MEC, where an Amazon Wavelength Edge Compute zone correlates these images with stock images of what it has to be. Any deviation in quality immediately gets triggered as an aberration, and remedial action is initiated back to the production line controller or to a supervisor as appropriate. This entire connected ecosystem of high-resolution cameras, the visual analytics ecosystems which operate out of these images, and the low latency response that is needed for remedial action, all of this has to happen near real time, which is exactly where Verizon's 5G, AWS's Wavelength, and our solutions come into play. The trial results out of this use case really illustrates how we can harmoniously bring multiple technologies to bear with 5G and edge compute together.
Thanks, Shanky. That's a very great example. You saw the cameras being used as a multifunction IoT sensor, if you like. You saw ML, you saw edge processing, both in the robotics and at the 5G hub. That's a great sort of end-to-end example there of what I'm talking about today. So let's talk about the rugged edge, because a lot of important data is collected at places that aren't very pleasant to be in some cases, but they're pretty important. And so for that, we have our Snowball family of products. We have our small device, like our snow cone here. I can show you one right here where it's got its ink label and stuff for shipping to give you an idea of the size. But these are ruggedized clouds in a box, if you like. They have cloud services built in. They allow you to build an application on the cloud, test it on the cloud, and deploy it to the edge. The devices have a whole bunch of encryption and security capabilities, anti-tamper capabilities. They have built-in logistics and shipping. They're ruggedized. They can handle very high impact, and they can operate at broad ranges of temperature, and they can be clustered. You see there in the center, one of our customers, they're rack mountable as well. That's got about a 1.5 petabyte cluster there and doing real-time processing at the edge. They can also be used to collect and transfer data, for example, in the movie industry, drone operations, those kinds of things. So it's about pushing the cloud out to that edge in disconnected environments, rugged environments, and mobile environments. We can deliver to there as well very effectively with Snowcone. It's also integrated with our IoT systems as well. As I mentioned, SiteWise is on it, and our IoT hub and things like that. Novetta is a great example of that. They do disaster recovery and construction and remote site operation centers, and you can see an example of it here set up and running. It can be set up very quickly, delivered very quickly, and then torn down very quickly, moved to another location if necessary. So let's talk a little bit about on-premise systems. When if you have a data center class environment, you don't need all that ruggedization of the ability to process AWS at the edge or a mobile requirement. We have a great product called Outpost. So Outpost is a data center class rack system designed for high availability and high compute with, again, layers of security. Security is always the number one thing at AWS as well. With our Nitro infrastructure, allows everything to be encrypted at rest and in motion, and no way for any of our administrators to see or access anything running in memory as well. And we're coming out with new 1 and 2U versions of this as well, so you can scale from very small to very large and even cluster these on-prem. A lot of our customers are using these to control their robotics and SCADA systems and other things like that at the edge. And a great example of that is Morningstar, who's using the Outpost as a migration strategy to move some of the stuff that has to run low latency on site, along with moving other things to the cloud where they can have the durability and scalability of the cloud with the lower latency. So let's talk a little bit about metro centers. This is where we extend an availability zone right into a city center or something like that, so we can get closer to customers. This is where you want that same elastic scalability. Again, as I said before, this sort of end-to-end consistent environment and consistent development environment, but now in a metro center. So when we talk about centralized control and decentralized execution, this gives you an example of the kind of products we have out there for you. We have the ability for you to connect and manage a large number of devices securely. We also have our LoRaWAN product where you can connect over low bandwidth wireless capability there as well, and satellite connectivity also. Deploy with things like Greengrass and Lambda functions and SiteWise, and also deploy out with CloudFormation, things like that out the edge to manage from end to end the environment on any on-prem environment or even on other clouds and things like that. And secure it end to end with Device Defender and things like that. Again, security is a really important piece for us. So one of the advantages of working with Amazon versus other cloud providers is that we have to do all this for ourselves. And so we've proven it time and time again for decades of experience here on how we can manage these very large scale environments out there with our IoT systems and our robotics and edge processing, along with our cloud processing, all integrated together. We have 175 fulfillment centers, 40 sorting centers. We have 50 of them that are robotic. We manage about 250,000 robots today, and hundreds of thousands of Alexa devices deployed all over the world. So this is an example of one of our automated fulfillment centers. And what you're going to see here is the Kiva robotic systems. They operate underneath these shelves, and they move the shelves through the pickers. The pickers are both robots and humans, it's interesting, we designed all this using simulation, and you can see the robots here working in swarms and bringing the product out to the pickers. It's really fascinating. The more random you have the products, the faster you can go, because you can do more in parallel. And you see these robots, as they move along, they're sensing each other and just avoiding each other. Again, there's some processing occurring on the robots and some processing occurring in the cloud, and you can see them operate and just barely miss each other in some cases here. And some of them will move quite quickly, and they're constantly rearranging the shelves and optimizing. On one side of the fulfillment center, there's product coming in. It's getting sorted and stored here, and then on the other side, it's going out to pickers based on orders that are coming in. Our service level agreement is from the time you click buy on the Amazon.com website, it's literally in a box, in a truck, on its way to you in 20 minutes or less. These robots have the ability to sense. If, for example, if a human were to walk in here, they would avoid it and set down and set off my pager and things like that, because there shouldn't be people in here normally. They have the ability to automatically maintain themselves in that they can go back and charge automatically. But this is an example of what you can do when you pull together IoT, robotics, edge processing, machine learning, all the things we've been talking about today. And we've been doing this for many decades. So we can help you do this and really accelerate the speed of your business. So let's talk about another customer who's done this, taking advantage of everything we talk about in this slide deck. So Woodside's a very innovative company down in Australia. They're an LNG and oil and gas company, and we'll be looking at one of their liquid natural gas plants today. They have a number of them that they've automated here. And again, they're not doing this just for fun. It's saving them millions of dollars every month in proactive maintenance and production operations on here, along with a number of other areas where they've streamlined their operations. So each plant has between 200 and 250,000 sensors streaming in AWS. They're using Amazon robotics and others locally to do the automatic checking of the plant. And making sure that inspections and safe inspections are running, along with taking a closer look, along with the robots can turn valves and things like that. They've taken this idea of putting lots of cheap cameras everywhere and turning the real-time video into sensors, so they can detect things and they can zoom in on them. They're running machine learning to optimize their operations and maintenance. They're doing edge computing with snowballs and outposts. And so it's a pretty interesting environment. So what you're about to see is their management environment, which is a nice 3D immersive environment that was done through a LiDAR collection and CAD CAM. And you'll see them switching back and forth here. So let's take a look. So what you can see there is a RoboMaker robot doing its rounds there with its LiDAR on it. And as they zoom in here, you'll start to see the data pop up in real time. It's streaming in through our IoT system so they can see exactly what's going on. As you stream in on these compressors or zoom in on these compressors in this 3D environment, you can see all the data as it comes in. When they switch to the CAD CAM view, you'll see it's slightly different, and they rescan it every month to make sure it's up to date. They overlay that with the video. I think they use to kind of reverse cluster on the LiDAR section and the point cloud. And so as you move around here, you get to see really what's going on. So you can see specifically what's happening. And they're using machine learning, for example, there to see the oil level and convert that image into a percentage so that they know exactly how much they've got there. And so what you do, they can also bring in the acoustics there you see is being streamed in as well. They're using Kinesis video for that also. And you can see they're doing an inspection of that pipe right there in the center that we can see there with the robot as the robot moves on. Now, a little bit further down, they've also can zoom in on any of the compressors to see what's going on. The machine learning models can interact with changes there. You can see the robot is doing an infrared camera a view down there of a system to make sure heat is being dissipated properly on a valve that the machine learning model has decided to change here. So the operator is going to take a closer look at that, at what the machine learning model has said to do here. And you can see that it's told it to open at 100% about 11 minutes ago. The robot has gone on and is collecting LiDAR there. You can see it doing its job as it goes through its inspection. And the operator's taking a closer look at this, and the operator's switching back to the LiDAR view now. And in the LiDAR view, you can see they're going to go check the next set of compressors. Those are people who didn't stand still long enough to get scanned by the LiDAR drone or the LiDAR ground mobility vehicle that did the scanning. And then again, they're going to zoom in here, see the status in real time off the compressors. That's streaming in through the IoT systems, applying the same machine learning model. So you can see that's also at 80%. They can listen, and this is a great example of basically applying everything I talked about here today. The edge processing, the IoT, the ML, the cameras, the robotics, and the machine learning to significantly save money and generate great business value. And they do this end-to-end with solutions that you can get right off of AWS today. So one of the important things to do is to get out there and learn and do some training. I always recommend the place to start anytime you do something in the cloud is to demystify it through training. We've got a lot of great training capabilities out there and a lot of great training sessions you can attend. There's about 25 free digital courses you can go out there and learn a little bit about IoT, learn a little about how to manage devices, what Greengrass has done, how the analytics can be done. It's a great place to start, along with connecting with AWS anywhere. We're happy to spend some time talking about how to do large-scale industrial deployments like this. We have a lot of experience scaling up, as I mentioned before, to billions of devices, and also very, very rigorous security. The security is used also by the military, so it's got to be top-notch security. So I want to thank you and for taking the time today. It's a brave new world out there, and we continue to evolve what's possible at the edge and more seamlessly integrate it with the slot with the a cloud at the back end. And I want to remind you to go ahead and complete your survey on this session so we can get your feedback. Thanks, and have a great day.